Okay, so we are online and ready to start. Let's check everybody. Just a second. Okay, so we are online and ready to start. Let's check everybody. Okay, I'm ready to start the dissertation defense of Bekissanova, Жанар, Болатовны, title synthesis, characterization and antibacterial activity study of composites based on natural adsorbents and silver nanoparticles. Submitted for the PhD degree on the educational program, Chemical Technology of Inorganic Substances. The dissertation work was performed at the Department of Physical Chemistry, Catalysis and Petrochemistry of Al-Farabi Kazakh National University, and on the basis of the Department of Environmental Chemistry and Bioanalytics at Nicolaus Copernicus University, Toruń, Poland. Scientific supervisors: Ospanova Aliya Kapanovna, Doctor of Chemical Sciences, Professor of the Department of Physical Chemistry, Catalysis and Petrochemistry, Al-Farabi Kazakh National University, Kazakhstan. And Miroslav Sprinsky, Ph.D., Doctor of Science and Chemistry, Professor of the Department of Environmental Chemistry and Bioanalytics, Nicolaus Copernicus University, Toruń, Poland. Okay, I think we have both scientific advisors present. Okay, I see. And the scientific supervisor or official reviewers are Shmakov Sergei Nikolaevich, Ph.D., managing editor of the American Chemical Society, United States of America. And Klimenko Alexei Nikolaevich, Ph.D., head of the Scientific Center for Radioecological Research of Shakarim University, Semey, Kazakhstan. I think we also have both official reviewers present. And the temporary members of the Dissertation Council, Matej Balash, Ph.D., Senior Researcher at the Institute of Geotechnics of the Slovak Academy of Sciences, Slovakia. Kozlovsky Artem Leonidovich, Ph.D., Associate Professor, Head of the Laboratory of Solid State Physics of the Astana branch of the Institute of Nuclear Physics of the Ministry of Energy of the Republic of Kazakhstan, Astana, Kazakhstan. Можаева Дарья Alexandrovna, Ph.D., Head of Research in the field of spectroscopy, BASF, Ludwigshafen, Germany. And Ефремова Светлана Владимировна, Doctor of Technical Sciences, Professor, Chief Scientific Secretary of the National Center for Integrated Processing of Mineral Raw Materials of Kazakhstan, Almaty, Kazakhstan. So I think we have all temporary members present, as I see. Yes. And we have two permanent members of the Dissertation Council, me and Scientific Secretary, Professor Tajibaieva. And we have a quorum, and we are ready to start the defense. Please keep your web cameras on during the defense. The defense is recorded and broadcasted on YouTube at the channel of the university. And I remind you that as a result of this defense, our Dissertation Council will make one of three possible decisions. First is to award the PhD degree. Second is to send the dissertation for another defense. And the third option is to refuse to award the PhD degree. Okay, so we are ready to start, and the screen is given to Scientific Secretary, Professor Tajibaieva Sagdat Medirbековна, for presenting documents available in the personal file of the applicant. Please.
Thank you, Botan Ivанович. Bekissanova Жанар Болатовна, born in 1991, and in 2013 she graduated from Kazakh National Technical University, named after Satpayev, as a bachelor in specialty chemical technology of inorganic substances. From 2014 to 2016, she studied as a master's student in Kazakh National Research Technical University in specialty chemical technology of inorganic substances. From September 2018 to June 2021, Bekissanova Janar studied in the Ph.D. program of the Faculty of Chemistry and Chemical Technology of Al-Farabi Kazakh National University. The topic of dissertation, research, and scientific advisors were approved at the meeting of the Academic Council of the Faculty of Chemistry and Chemical Technology on 29th October of 2018, protocol number 2. In the personal file of Bekissanova Janar, there are copies of bachelor's and master's diplomas, a list and copies of published articles, positive reviews of scientific supervisors, protocol of enlarged meeting of department, and all other documents in accordance with the regulations of Committee for Quality Assurance of Education and Science of the Ministry of Science and Higher Education of the Republic of Kazakhstan. The main research results on the topic of the dissertation are presented in 15 published works, including 5 articles in an international journal from by the date of Scopus and VOS, materials with quartile 2 colloids and surfaces, Seria B, biointerfaces, quartile 1, biomimetics, quartile 2. And the 3 articles in rating publications recognized by the Committee for Control in the Sphere of Education of the Republic of Kazakhstan, 5 abstracts included in international conference proceedings, and 2 patents of the Republic of Kazakhstan. On 30 of June 2023, the work of Bekissanova Janar was discussed at an enlarged meeting of the Department of Physical Chemistry, Catalysis and Petrochemistry of Faculty of Chemistry and Chemical Technology of the Al-Farabi Kazakh National University. The meeting was attended by 34 people. First reviewer, Murzagulova Kunnaz Baymukhanovna, Doctor of Chemical Sciences, Professor of Department of Chemistry and Technology of Organic Substances, Natural Compounds and Polymers. In her positive review indicated 3 comments. Second reviewer, Shalabayev Jandos Magulovich, Ph.D. Doctor, Deputy Director of Scientific Center for Anti-Infectious Drugs, also gave a positive review indicating 4 comments. All the asked questions and comments of the reviewers received answers, and therefore the scientific seminar unanimously recommended the work for defense. Extract for protocol number 15 dated 30 June 2023 was approved by the Vice Rector of for Academic Affairs Erkimbayeva Lezat Kalimbekovna. The date of defense, official reviewers and temporary members of the Dissertation Council were appointed on 20 of March 2024, protocol number 3, as the meeting of the Dissertation Council. Thank you for attention.
Okay, thank you, Professor Tajibayeva. Dear colleagues, do you have questions to Scientific Secretary? Okay, thank you. If there are no questions, then we are ready to continue, and the screen is given to the PhD student to present the content of the dissertation. The time is 20 minutes.
Good afternoon for everyone. Okay. And did you see my screen?
Yes, everything is okay.
Okay, good afternoon for everyone, dear ladies and gentlemen, and I would present for your attention my PhD thesis, Synthesis and Characterization and Antibacterial Activity Study of Composite based on Natural Adsorbents and Silver Nanoparticles. Supervisors, Professor Ospanova Olega Panna, Professor Miroslav Sprinsky, Torun Nikolai Copernicus University. And the relevance of the work. In the practical medicine, it's important problem to produce a composite with antibacterial and anti-inflammatory properties. And the composite who plays the support this of obtaining, it can be natural matrices like a diatomite, kaolinite, and diatomocellulose biosilica. Diatomite widely used in the industry like to fillers, in the water treatment, in the construction material, agriculture, and this exported from other countries like feed additives and diatomite products for humans. And the Kazakhstan has a huge deposit in the Oktober region, is Mugajar deposit. It is this amount of 1,800 million tons. And the kaolinite clay mineral, which located on the Kokshetau region, Alexeyevsky deposit, with amount 260 million of tons, and widely used in the ceramics, plastic, and paper industry, in pharmaceutics, and is a hemostatic agent, but in another country, not in Kazakhstan. The diatomocellulose biosilica, which obtained from microalgae, can use for thin technologies. It is this solar cells, bone tissue engineering, biosensors, and in the opticals. And why did we choose this material? Because they unite the properties of this. It is the static compatibility, biocompatibility, and high bactericidal efficiency, prevent agglomeration and emission of the cellular nanoparticles in the environment. This material can be unstable and prevent agglomeration of the cellular nanoparticles. And composite based on natural supports with cellular nanoparticles used like feed additives, wood dressing, antibacterial water treatment, like drug delivery system, and the food packing materials. And the scheme of PhD thesis and aim of the work. The aim of this work is to synthesize of silver nanoparticles and silver chloride nanoparticles on the surface of natural adsorbents and study the antibacterial activity against gram-positive Staphylococcus aureus and gram-negative Klebsiella pneumonia and Escherichia coli. And the first part of the defense, it is this synthesis and antibacterial activity of hybrid composite with silver chloride and metallic silver nanoparticles on diatomite. And the second, it is the synthesis characterization of silver kaolinite nanocomposite and studying its antibacterial activity. The third part, it is the synthesis and antimicrobial activity of 3D micro-nanostructured diatom biosilica coated by epitaxially growing or silver chloride hybrid nanoparticles. And the characterization of nanocomposites was instrumental in physical-chemical methods of the research. The morphology and structure of natural adsorbents was studied by scanning electron microscopy, and the elemental composition of natural adsorbents and composites with silver nanoparticles, silver chloride, was studied by SEM-EDX spectral analysis. The changes of temperature and physicochemical changes studied by thermogravimetric analysis, and the mineral composition and formation of the silver and silver chloride nanoparticles studied by the X-ray diffraction, functional rules by FTIR spectroscopy, and distribution, size, and shape of nanoparticles by transmission electron microscopy. And the first provision for the defense, a new composite material with antibacterial properties based on natural adsorbents containing 0.71, 4.65, and 7.21% of hybrid nanoparticles with size from 1 to 2 nanometers of silver chloride and metallic silver nanoparticles can be obtained by immobilization or formation of silver nanoparticles on the surface with ion exchange reaction and reduction with chemical reduction reducing agent hydrogen peroxide. And the amount of silver chloride nanoparticles can be limited by the impurity of the halides on the natural diatomite. And the synthesis composites show a high antibactericidal efficiency against Staphylococcus aureus and Klebsiella pneumonia with minimum inhibitory concentration of 5 and 10 milligram per milliliter respectively, with content of 0.71% of the composite. And this provision was published in the article Materials, and confirmed the following of results. And the diatomite with has good absorption properties, and we has a huge amount in Kazakhstan. And the before was studied, the physicochemical characteristic was studied by scientific school professor Bekissanova, and we investigated of same index spectral analysis, SEM, and X-ray diffraction and other physicochemical analysis. And the amount of chemical elemental composition on the figure 1, and the main elements, it is the silicon, aluminum, and oxygen, and the minor amount of potassium, iron, titanium, calcium, and magnesium. And the structure of natural diatomite in the figure B, we can see some numerous of the fructose with pores from 0.8 to 1 micrometers, and some laminated layers, particles of the clay minerals. And it is phenomenon was confirmed by X-ray diffraction. The main minerals on the diatomite, it is this quartz, kaolinite, elite, and halite. And we can see the peaks of the diatoms fructose. It is this amorphous quartz from 20 to 35 degree. The main functional group, it is this vibration of OH and HOH, COC, CO aluminum bending. And the changes of the temperature depending the mass losing equal to 10%. It is this water was bonded on the surface and bonded with the selenol groups. And the experimental part of synthesis of the hybrid composite, the diatom mass was impregnated with silver nitrate solution with 3 concentration, initial concentration 1%, 5, and 10% of the silver ions. And the first, it is ion exchange reaction and formation of silver chloride. And after that, excess amount of the silver was basified with sodium hydroxide and reduced with reducing agent hydrogen peroxide to formation of silver metallic nanoparticles. Then they washed and dried and obtained the hybrid composites with silver chloride and metallic silver nanoparticles on support to diatomite. And with initial concentration 1, 5, and 10%, the amount of absorbed of silver equal to 0.71, 4.65, and 7.21% of the silver. And the elemental composition presented in the table 1. And we obtained a hybrid composite with amount of silver chloride and metallic silver nanoparticles. And the mass fraction and the ratio between of 2 nanoparticles was calculated and presented in the table 2. For this composite 0.71, it is equal to 98 to 2. For second composite 71 to 29, and the third for it is equal to 51 to 49%. And the formation of the silver chloride and silver nanoparticles in the mineral composition was confirmed by X-ray diffraction, and we can see the peaks of 2 degree, and the metallic silver equal to 38, 44, 64, and 77, and the chloride nanoparticles equal to 26 and 32 and 46. And the distribution of size of nanoparticles by transmission electron microscopy, we can see the some uniformly distributed and quasi-spherical nanoparticles with predominantly size from 2 to 5 nanometers. Also, the nanoparticles from 1 to 2 and from 8 to 10 nanometers with a different concentration. And the antibacterial activity of hybrid composite based on diatomized with silver chloride and silver nanoparticles was investigated in Interdisciplinary Center of Modern Technology in Nicolaus Copernicus University with development standards with Dr. Viorica Rallen against 2 bacteria, Staphylococcus aureus and Klebsiella pneumoniae. And we can see the amount of the minimum inhibitory concentration of the composite. It is for with concentration 0.71, it's equal to 5 milligram per milliliter. And this is a concentration of the silver chloride nanoparticles and metallic silver nanoparticles in the amount of the concentration. And against Klebsiella pneumoniae, it's equal to 10 milligram per milliliter, and the amount of this silver on this composite. And the second provision for the defense. And layered and clay minerals widely used in pharmaceutics and in the medicine. It is like a kaolinite clay mineral and located in the Koshitao region. And this is second defense for provision composite materials based on natural kaolinite containing 0.6, 2.05, and 7% of nanoparticles with size from 20 to 50 nanometers are obtained by chemical reduction and using environmentally friendly reducing agent hydrogen peroxide, and can exhibit antibacterial activity against gram-positive Staphylococcus aureus and gram-negative Klebsiella pneumoniae and Escherichia coli, with minimum inhibitory concentration 10 mg per milliliter and silver content of 7% on the composite. This provision was published in the article Colloids and Surface B Biointerfaces and be supported by the following results. And the kaolinite located in the Alexeyevsky region, it is the first time was studied and physical-chemical characteristics was obtained of this material. This is a layered material with tetrahedral sheet of silicon oxide and octahedral sheet of aluminum oxide, which link it with oxygen, and the distance between of these sheets equal to 0.97 nanometers. And the main elements in the mineral, it is aluminum, silicon, and oxygen in the minor amount of the potassium, calcium, titanium, and iron. And the structure, it is like a book of sheets, box stick. The functional groups is the vibration of aluminium OH, COH bonding, CO, aluminium OH, CO, and COC vibrations. The mineral composition shows the main mineral, it is kaolinite, also has light and quartz. The transformation of temperature, the mass losing for 50%, and we can see the transformation from kaolinite to metakaolinite of the temperature and from metakaolinite to molybdenite phase of crystalline. And the experimental part of synthesis of silver nanoparticles kaolinite composite, the kaolinite was impregnated with silver nitrate solution, basified and reduced with environmentally friendly hydrogen peroxide reducing agent. Then washed and dried in the temperature on 110 degrees. This studied the physical-chemical properties of the obtained composite and antibacterial activity. And the concentration initial was 1, 5, and 10%, and the absorbed silver was 0.6, 2.05, and 7% of the silver based on kaolinite composite. And we can see the same EDX spectra and mapping of the distribution of the elements on the structure on the kaolinite with different concentration of the silver. The formation of the silver was confirmed with X-ray diffraction, and the formation in the peak on 38 and 44 and 64 and 77, it is this 2 theta degree was confirmed of the silver formation on the kaolinite. And the size distribution was studied in the micrograph stems, the predominant size from 20 to 15 nanometers, and also they have some twinned crystallines of the silver. The zeta potential of the effect of the zeta potential depends on the pH. You can see some stability. It is more stability in the pH 4 and the pH 11. And the photoluminescence, some of the peaks for unnatural kaolinite and the composite which obtained in different concentration, and the peaks on 445, it is can indicate of the formation of the silver from 25 to 15 nanometers nanoparticles. And the antibacterial activity of nanocomposite based of silver and based on kaolinite with silver nanoparticles was studied against 6 strains. It was American typical culture collection and wound isolates from diabetic infections and wound isolate. And the composite with different concentration of silver and this concentration with 7% of silver nanoparticles show antibactericidal efficiency against all bacteria, but the second component only Klebsiella pneumoniae and Escherichia coli, and with containing on 0.6 against Klebsiella pneumoniae American typical culture collection. And the third provision for the defense. The kaolinite and diatomite has a main compound, it is the silicon oxide. And the diatomaceous biosilica, it is this pure biosilica obtained from microalgae, it is pure silicon oxide. And the third provision for the defense, it is a new 3D micro nanostructured composite material based on biosilica containing epitaxially hybrid integrals of metallic silver and silver chloride nanoparticles. And with predominant size from 5 to 25 nanometers and some crystalline twin is axially twinned and layered twinned, shows a high antibactericidal efficiency against S. aureus and gram-negative Klebsiella pneumoniae and Escherichia coli with minimum inhibitory concentration 1.25 milligrams per milliliter and silver content 4.61. The defense provision for defense was published in the article Biomimetics and can confirm with following results. And the diatomaceous biosilica was obtained by a scientific group of Professor Miroslav Sprinsky and Nikolai Copernicus University. The setup of growing and purifying of the atom biosilica, the experimental part of obtaining the composite is content of the stage 2 impregnation of silver with silver nitrate solution to diatomaceous biosilica, artificially adding to sodium chloride, basified and reduced with hydrogen peroxide, and obtaining hybrid nanoparticles, silver chloride and metallic silver nanoparticles, and investigated with physicochemical analysis. And the diatoms cultivation and the microscopy, lighting microscopy of the living diatom, and the scanning electron microscopy studying after purification of the diatom biosilica with pores, nanopores. The spectral analysis of same images and the mapping of the obtained nanocomposites with different concentration. It is initial concentration was 5 and 10%. The adsorbed of silver equal to 4.61 and 8.49, and we can see this distribution of the pure silica and with after that of modification with silver and chlorine ions on the mapping. And this is of hybrid particles and hybrid composite with content of metallic silver and silver chloride nanoparticles. And this is ratio between of two particles, silver chloride to silver nanoparticles, equal to 86 to 14 and 51 to 49 for two composites. And the formation of silver chloride and silver nanoparticles, the mineral composition was presented in the figure, and the broad peak of the opal A, it is this amorphous silica from 20 to 35, and the formation of silver chloride and metallic silver nanoparticles on the surface on diatomaceous biosilica presented in the figure. And the figure next, it is transmission electron microscopy study. And the nanoparticles distributed on the surface and from the predominant size from 5 to 15, and with crystalline layer twin and axially twin crystalline. And the STEM analysis of one particle showed that it is hybrid particle, and the nucleation was from the first nucleation formation of the silver chloride nanoparticles on the surface of the atom biosilica, and after that covered top on this particle with metallic silver nanoparticles, and the model of the epitaxially growing the particles. The potential on depending on the pH of natural biosilica and the composite and this photoluminescence, and this we can see the peaks in the this to show the particles up to 10 nanometers and particles up to from 22 to 25 nanometers. The antibactericidal activity against 6 strains, it was American typical culture and wound isolate diabetic foot infection and isolates from wound. It was studied, and the phenomenon shows that the natural biosilica shows the antibactericidal efficiency against Staphylococcus aureus and Escherichia coli. And the minimum inhibitory concentration of the composite equal to 1.25 milligram per milliliter, and this concentration of the silver in composite and the concentration of the silver chloride and metallic silver nanoparticles in the composite in 2 concentrations. And the 4 provision for defense. The antibacterial activity of hybrid silver nanoparticles has a synergistic effect, and all obtained synthesized composite was studied against gram-positive and gram-negative bacteria and show a greater inhibitory efficiency. And against 6 strains, it was American typical culture and clinical isolates diabetic foot infection. And now, in the modern scientist has a theory of the damage of DNA and ROS, generation of the ROS, and inaction of the enzymes and cell of destruction of the cell membrane. And we can postulate that our particles destruction in the bacteria with generation of the ROS. And as the process of flow diagrams of synthesis of composite based on natural adsorbents presented in the slide, and this is of process of obtaining hybrid composite of silver chloride and metallic silver nanoparticles with a stage of the washing, hand crushing, absorption, and stage of the preparing this hybrid composite. And the kaolinite, this has a stage of preparing the nanocomposite with silver nanoparticles based on kaolinite, this hand crushing, turbulence, decantation, drying, and classification. After that, obtaining the composite. And the next process flow is obtaining the hybrid composite based on the diatomaceous biosilica with silver chloride metallic silver nanoparticle with cultivation, purification, centrifugation, microalgae, and obtaining the diatomaceous biosilica, and the stage of the obtained nanocomposite with adsorption and reduction and washing of obtained composite, drying. And the next, this is conclusion. And the original method of synthesis hybrid composite based on diatomite was developed with a different concentration 0.71, 4.65, and 7.21. And the presence of metallic silver and silver chloride nanoparticles was confirmed with X-ray diffraction, and the size of distribution was studied by transmission electron microscopy with size from 3 to 6 nanometers, and synthesis hybrid composite showed antibactericidal efficiency. And the second alkene to nanoparticles kaolinite composite with metallic silver nanoparticles synthesized with 3 concentration, and studied the physicochemical properties, the formation with X-ray diffraction of metallic silver with size from 20 to 50 nanometers. And the synthesis composite showed antibactericidal efficiency against 6 bacteria, 6 strains, and diabetic foot infection and wound isolates. And the third and new hybrid nanoparticles based on diatomaceous biosilica with epitaxially growing was synthesized with a 2 concentration and with predominant size from 5 to 25 nanometers, and show high antibactericidal efficiency with minimum inhibitory concentration 1.25 milligrams per milliliter. And for all new antibacterial composite obtained based on natural carriers on diatomite, kaolinite, and biosilica, and production were developed. And list of publication in the Scopus, patents, and the articles, abstract in the international conference proceedings, and acknowledgement for the Ministry of Education of Kazakhstan for funding the projects, and also the program PROM from NAVA. It is European Union scholarship. And also I was to gratitude my supervisor, Professor Miroslav Sprinsky, for supervision and supporting, and thanks for valuable contribution and the experience to PhD thesis, to Professor Spanova Lekapana, to mentoring and support during doctoral studies, Al-Farabi Kazakh National University, Department of the Physical Chemistry, members of Laboratory Nanocoatings in Nanomaterials, the Center of Modern Technology Nikolai Copernicus. I'm grateful to co-authors, family members, and friends for supporting. Thanks for your attention.
Okay, thank you. So, dear colleagues, do you have questions? If you have questions, just raise your hand using Zoom, or just I will try to catch your hand on the video. Okay, Professor Balash.
Thank you very much for this nice presentation, and in general the work, I think it is very interesting. So just before the presentation, I went through the 3 papers that are like the main results, you know, of your study. So I have some questions regarding the presentation. So if you can go back to slide 6, please. I just saw some very interesting structure there, and I couldn't catch exactly what you meant. So in this picture B, yes, in the SEM image, so on the left side in the middle there is something like hexagonal structure. So what is it coming from? Can you tell me, please?
The structure of the diatomite.
Okay, so this is the diatomite like support, yes, on the left side.
Yeah,
okay.
this support. Yeah, this support.
All right. Then if you can go to next slide, there you have this nice scheme, and actually you in this third picture there is still halide present, yes, sodium fluoride. So actually I guess then it stayed in your sample also after drying, or is it just a mistake, or is it, I mean, is it still there, this halide, in your final product?
And we dried after of obtaining the composite with the silver. We dried in this temperature. Okay.
Yes. But I mean, in the third picture, you still show like silver. Sodium chloride. Yes, in the bank, it's written there in blue color. So I mean, if you got rid of it, or is it still part of your product?
Yes, sodium chloride, it is impurity, halide, mineral impurity in the diatomite. Yeah, natural impurity. Mm-hmm. This diatomite contains this impurity, and this was, and after that, the formation of silver chloride, the reaction with silver, it was brought with sodium chloride in this halide, and after that, we reduced amount of the silver which didn't react with the halide.
All right. So some part of this halide was reacted with silver, and some part like remained. Okay.
Which was excess of the silver. For example, the small amount of the halide was reacted with the silver, and the except with a different part was reduced with the hydrogen peroxide and was obtained metallic silver.
Okay. Perfect. Then on slide 8, actually, it's like quite general question. How exactly was the ratio between the silver, I mean elemental silver, and silver chloride made? It was based on the EDS results, or?
Mm-hmm. And we calculate from same EDX. It was the amount of the silver and amount of the chlorine ion, and which of reacted with the silver, and this is in molar fraction, moles of the silver and silver chlorine. And we can see the mole of the silver and the mole of the chlorine, and this amount of the mole of the silver chlorine, this is amount of the metallic silver, which doesn't react with this halide, with excess of the silver which reduced. And it is the same. Mm-hmm. For example, in the next diatomite, the composite has the concentration 4.65, and the mole of the silver and the mole of the chlorine, which reacted with the halide, and this amount of the metallic silver which reduced, which of excess. This was amount of the ratio between 2 nanoparticles.
Okay, I have here a question about the silver content, which you like determine, for example, that it's 4.65%, so or 0.71. I mean, this is done also from EDS analysis, I guess, yes. And how many samples have you analyzed to reach this value? Because I saw later that this was like an average or more measurements, but of course, it would be nice like to provide this information if it is like an average value or it's just from one region, because if it would be just from one, I think it would be not like statistically correct, yes, to give this value. So
Yeah, understood. Thanks for question. It was not only one time. It was it was a different part of the structure on the FMI, and it was a mean of this 5 or 4 mapping of this and distribution on the area.
Okay. Okay. I guess then this is just my like recommendation, and if I would have the same results, I would maybe also use the XRD analysis to determine the ratio between silver and silver chloride. It can be done by various methods like Rietveld refinement, for example. And in this way, usually it's like more often used than to determining the ratio between, I mean, using SEM EDS, but of course it's a way how to do it. So that's just my comment. Then is it okay if I ask like 4 more questions, Mr. Chairman?
Yes, sure. As many as you wish.
Oh, all right. So then if we go to slide 13, so you use the ratio between silver ion to hydrogen peroxide 1 to 3, yeah? So why exactly this ratio was used?
We analyze the literature because the works of scientists use some different reducing agent, tetrahydroborate and formaldehyde, and some and the ratio 1 to 4, or we choose 1 to 3 because after that we washed 5 times after reducing, and it is enough amount to reduce silver.
Okay, and here you say that actually it's like a 2-step process. So at first you produce silver oxide and then it is turned into silver element. So do you have any like let's say spectroscopic proof of actually the presence of the silver oxide?
No.
Okay, so it's just based on let's say literature and the mechanism how this reaction should run.
Yeah, this was methodic. Yeah, we analyzed and we choose this methodic because it is and oxygen of the silicon, it's not stable. It's not stable, and that difficult to precipitate on the support. And it was immediately to basified, and after that to reduce. It's not for a long time.
Mm-hmm. Okay, then on slide 16, you showed zeta potential results, and there the difference between, for example, the sample containing 2 and 7% of silver is almost, there is no difference at all in the pH higher than 6, for example. Do you have any explanation why the results are so similar for these samples?
For 7?
Yes, the red and this gray curve, yeah, why they are so similar?
I think it is was of more silver on the surface and the changing of the zeta potential. It depends of this when the silver was absorbed on the support, is the potential it is changed, and this 11 it is more stable. It is stable for when stable of the silver on the support and optimal pH.
Okay, and then if you can go to slide 23, so actually this part of work, I think it is very interesting. Also with this, let's say, some kind of layered structure that you have silver chloride and then you have silver nanoparticles on that. But I would like to ask about part C of this picture on the right, so the TEM analysis. Actually, when we are doing TEM analysis, I am not very familiar with these graphs where you like have the position and atomic percent. So it may be more light question, but I can see that in the chlorine, yes, there is a peak around 10 nanometers. Yeah, the highest peak is there, and for silver in this region there is like a value close to 0. Yes, in this part. So what does it mean? It means that there is like chlorine which is not part of the silver chloride still present there. Do you understand my question?
Yeah, I understand why from not 0 from chlorine and from 0 to to silver.
Yes. I'm sorry. I guess these graphs work like this, that if you have like higher amount, it means that this atom is present there, right?
Yeah, because it is this amount of the chlorine and amount of the silver, and we try to make the model how it will be the model of the silver chlorine and the silver nanoparticles, and it is from instrumental, yeah, and I can explain for this why from 0 and from.
Okay, because I just see that, let's say, these two hills in silver are in good agreement with the small hills in chlorine, yes, but on this peak on the left there is a big one, yeah, in chlorine, and in silver it's like down. So, but yeah, that's fine. And very last question about the patents you have. So I saw that you have just Kazakh colleagues on those patents. If I saw properly, I was looking at the one you have on slide 11. And yeah, my question is just, I see that you had very good cooperation with Polish colleagues. So yeah, why they are not included into the patent, or was this part of work done just in Kazakhstan?
From Kazakhstan with my supervisor, Bekissanova, and me and the Polish colleagues.
My question is related to the patent, because I see in the
okay, about the patent, it is we have another result to obtain with kaolinite with activated with the acids, and yeah, it is we have another results of the kaolinite, yeah, and we use the different reducing agent. It was ascorbic acid, and it is a patent of the different part of work, but with kaolinite, yeah.
Okay, perfect. Thank you very much. So
okay, thank you for my question.
Yes.
Thank you. Professor Efemova, your microphone is off. Microphone.
I'm sorry. Good day, everybody. Thank you, Zhanar, for your interesting work and report, but I have some question. I couldn't recognize clear information in slide number 27. 20?
27.
Could you explain, please, in which way do you use results of thermal analysis to produce your composites?
Which analysis? Sorry, thank you for question. Thermal analysis.
My question is, in which way do you use results of thermal analysis? Why did you carry out thermal analysis? Why?
Why did we carry out the thermal analysis for composites? Not composites. It was for natural adsorbents.
Yes.
For natural adsorbents, so characterization of the amount of the water and amount of the losing of thermostability of this natural adsorbent. It was for that.
I see. And you use only drain at 110 degrees.
Yeah, it was drying the composite. Yeah.
Mm-hmm.
Yeah, because we only lost the water which absorbed on the surface on the natural adsorbents.
Thank you. You wrote that silver chloride nanoparticles have more strong antibacterial activity. So it is very important to produce silver chloride nanoparticles. But maybe it is possible to use silver chloride solution to immobilize these particles on the surface of natural mineral.
Thanks for question. And the silver chloride has more antibactericidal efficiency against if we compare with metallic silver. It is the work from the one article from after of Naik. It was obtained of SBA-15 mesoporous silica, and was compared two particles only with silver chloride and only with metallic silver. And silver chloride nanoparticles show efficiency, the concentration too lower than metallic silver. And the works with the investigation of the metallic silver and silver chloride say that the silver chloride has more cytotoxicity than metallic silver. And the next was when we precipitate the silver chloride solution, we can adsorb all of silver chloride on the support, because some it will be in colloidal, it will be on the precipitation without support, and it's more effective to precipitation and obtain the silver chloride on the support and prevent agglomeration.
Why did you add sodium chloride in the third experiment?
Yeah.
To produce silver chloride nanoparticles?
It will be one pot method to obtain two particles in the one pot method, and adding to artificial sodium chloride, and in this time to the amount which sorbents on the support with formation of the silver chloride, and after that to cover it with metallic silver to obtain hybrid particles.
Which method did you use to confirm concentration of silver nanoparticles in composite?
Semi-Dix spectral analysis.
Only one.
Only one. Yep.
But you know that this analysis show the concentration of elements only in a certain point of the surface.
Yeah, I know about, for example, ICP method to confirm the silver in the solution, but it is depend on the equipment which we can use for study to make the research work. We have only the opportunity working with Semi-Dix and identify the silver with this method.
Thank you.
Thanks for questions.
Thank you. Okay, dear colleagues, other questions?
May I ask you?
Yes, sure.
Thank you very much to applicant for very nice presentation, and I have some questions. So if you put slide number 9, please.
9.
So could you explain me or us how you obtain this how determine the
size of nanoparticles.
Determination of by size?
It was the problem when we downloaded the 10 micrographs to MHG and calculated the area, and this calculated the size of nanoparticles, and after that we analyze in origin.
Okay. So did you use MHG software? Yeah.
Yes, software. Yeah.
Okay. Okay. This is answer my question. Thank you very much. So and slide number 16.
16. Mm-hmm.
Yeah. So how you prepare the samples for zeta potential analysis? It was a solution, or it was some suspension of your nanoparticles? How you prepare the sample? Yeah.
It was a suspension. It was 0.05 milligram of materials with a different concentration or with a different pH. It was the pH, different pH, and after that I suspend in the ultrasound bath for 360 minutes. And after that, we are analyzed in this 96 plates, put the suspension and analyze the data potential.
Okay. And it is very interesting. Why you say 3D nanoparticles? I don't. Sorry, maybe it's a crazy question, but why 3D?
Not 3D. It is a diatom biosilica 3D nanostructure. Diatom biosilica. Maybe when I said my reports make some mistakes when I'm speaking, this was 3D micro.
So 3D micro nanostructure diatom biosilica. I mean, why 3D?
Because this is material. It is three-dimensional. Not two-dimensional. It is three-dimensional. It is with a volume.
Yeah. What about the first and second? Your provisions. There is not 3D nanoparticles or composites. Was it 2D or 1D?
We decided to call this material, and not we decided it is calling in this articles like that 3D micro nanostructure, and the different materials, because the scalanite, it is layered. Layered structure. We can talk this 3D, and I don't think about why didn't I talk 2D.
Yeah, and last question, did you compare the concentration of your nanoparticles in the case of antibacterial properties with other types of antibacterial materials? I mean, some antibiotics or something like that, or just argentum nitrate?
Yeah, we compared with chlorhexidine and triclosan. Yeah.
Yeah, and how it was? Better or?
But it was not my test of my research work. It is, but it was the concentration 0.005, and the different method to obtain the composite and the different task of work. And now it is working. Now we are investigating this part, yeah, with different antibacterial agents.
Okay, so thank you very much.
Thanks for questions.
Okay, thank you. Dr. Shmakov, do you have questions?
Yes, thank you. Well, first, congratulations to Zhanar and Bolatовны on this interesting work. Even I learned something from this. That's impressive. So congratulations on that. So I have several questions, and so one of them is going back to the zeta potential, I think what I didn't get is on the zeta potential is why was it important to study zeta potential? What information did you get from the study?
And this information can get us to the proving of this silver nanoparticles was absorbed on the surface of the natural minerals and the stable, because we can see the difference after modification.
All right, okay.
Mm-hmm.
Okay, got it. So on some of your slides, you indicated how many nanoparticles you used to calculate the size of nanoparticles. But on other slides, it's not clear how many nanoparticles were used. So what typical number of nanoparticles you used to identify the size?
For example, for first composite with diatomite, we can see the size of nanoparticles in the histogram.
Mm-hmm.
Yeah, from 2 to 6 predominantly for this concentration. And for composite based on kaolinite, was twins. Yeah, this was twins. We can see this some clusters of nanoparticles.
Okay, yeah. The question is, how many nanoparticles did you use to make this histogram?
Mm-hmm. I tried this all from microphotographs used. All
So
it was approximately 120, 115 nanoparticles.
Okay, so I think the gold standard for statistical analysis of this type is like at least 300 nanoparticles. But thinking of this in the bigger picture, there are like millions and billions nanoparticles. So you only take like 150 to determine the size of the sample. So that's why it's also important to use other methods to validate your results. For example, XRD analysis. So did you use any other methods to confirm your sizes?
No.
No, you did not.
I don't use XRD for confirming the size.
Okay. Okay, it's good to know. So I have other questions here, if you don't mind. So does the composition of the diatomite affect the antibacterial properties of these materials? So, for example, did you compare your diatomite with any other diatomites that reported before?
Yeah, sure. We compared with the results. So I can show the antibacterial activity. We compare the results with diatomite. The one work with diatomite when nanoparticles were stabilized with stabilized and obtained silver nanoparticles, and there was concentration of this the same, and this also depend of the initial concentration of the silver. And for example, in our composite, the minimum inhibitory concentration 5 milligrams of composite, but they contain on 0.71% of the silver, and the amount of the silver 0.036 milligram per milliliter. And the different result, it is this minimum inhibitory concentration equal to 10 milligram per milliliter in different bacteria, 2.05, 5 milligram per milliliters, and some as the concentration lower, some it is the concentration higher than our works.
Okay, that's good. That is good. Okay. Did you study how the size of nanoparticles affect the antibacterial activity?
I can show. I compared the size of nanoparticles in the one composite with the initial concentration 10% with the absorbed these three composites, and we can see the size, for example, on diatomite from 4 to 6 nanometers, and biosilica from 5 to 15 nanometers, and for kaolinite from 10 to 15 nanometers. And when the nanoparticles is bigger, then its antibacterial activity is lower, because when the particle is smaller, then more active, they more dissolved in the solution and more active and destruction of the bacteria. And why of the difference between of the diatomite and diatomacellose biosilica? Because diatomacellose biosilica, it is pure material. It is the synergistic effect of silver chloride, and the diatom biosilica has antibacterial activity nature. And the different size, for example, if compare that. But if compare diatomite and kaolinite, it is more active small nanoparticles than big.
Okay, that makes sense, because typically smaller nanoparticles in general have much bigger surface area. So probably that's one of the reasons. Okay, that makes sense. Okay. So I have one last, but I think big question is, what is your personal contribution to this work? I saw a lot of co-authors on all of your papers, so it's not clear which experiments you did personally.
Or for articles where first after I did all experiments.
All experiments, including antibacterial experiments?
Yeah, including not only with Dr. Vera Kalainen, we made it together with minimum inhibitory concentration. Yeah, this work we dissolved this new Hilton solution and dilution method dilution method of this concentration with composite, and we added risazurin. It is this indicator where, for example, where bacteria died or where is this inhibition growth or non-inhibition growth here in this method.
Okay. I don't have any immediate questions.
Okay, thank you very much. Dr. Możaeva, please.
Thank you very much for the presentation. And I have following questions. So you presented the results of SEM EDX analysis, and there you then used the values to calculate the molar ratio and so on. And what was the spot size of the when you do the SEM? What was the spot size? What how many points were taken? Oh, okay. Already, this question was already asked, but I think it's important. And also, was the instrument calibrated, and how was it calibrated?
Have the instrument calibrated in the analysis?
Yes.
In the EDX or X-ray diffraction?
I'm talking right now about the elemental analysis, about EDX. Yeah.
About EDX. Okay. I prepared the samples and I gave the operator of this, and they have to prepare these samples and the calibration. I can't give the answer of that because I didn't make this this part to with calibration of this equipment.
Okay. Because would you maybe suggest some other methods that could be used in order to determine the concentrations of the elements in the composites? Like, if you have unlimited equipment, what would you do?
About to determine, thanks for question, about to determine of silver on the composite, yeah.
Well, you presented 15 or 10 or 15 results for the different elements, yeah. What are the alternatives?
Another methods to determine of the silver, we determined with semi-Greek.
Let's talk about silver, yes.
And I know about this ICP, yeah, and of course, two is UV spectroscopy. Have to the peak of the for nanoparticles, it is for 480 to confirm that. And no X-ray diffraction, yep. Formation of these crystallines, yep. That's what I know.
Yeah.
And transmission electron microscopy, the size distribution.
If you have the ICP, you're talking about the ICP OSO or ICP MS analysis. Your samples are solid, and for the ICP analysis, they need to be liquid. Can you comment on that? Like, what can be used to?
About
samples.
About ICP analysis here, I don't have opportunity to use this for my work. I didn't looking for the equipment where I can use that. Yeah.
Okay. Then other questions. When you did the synthesis of the composites, how many times did you perform the synthesis? Also about statistics.
About statistics of composite?
How many times did you perform the synthesis?
How many times did I perform the synthesis?
Yeah.
Okay. For synthesizing of approximately for one synthesis, one composite, I spent for 6 hours. Yeah. After that, I'm put on the drying for 12 hours. That's if I calculate all time, it will be 18 hours for one composite.
Did you do it once, 2, 3?
I can be the parallel. Yeah, I can put 3 glasses and take 3 concentration. Yep. And after that, I centrifugation, washing, and it will be. Yeah. For example, in one day, I can prepare composite, 3 composite in different concentration.
My question goes in the reproducibility of the synthesis. That's why. Yeah. Is it reproducible?
Yeah. Reproducible.
So how many times?
For example, in this in not laboratory, in the factory, you think how it will be spent an time?
Not times. Daria was asking about how many times you repeated. How many replicate synthesis did you do?
3 times. 3 times.
Okay. Thank you.
Thank you.
Then I also read the article, and there and in the beginning you were also talking about the use of the composites for the wastewater treatment. Is there a possibility that silver ions then afterwards will end up in the wastewater treated by this composite, and is it dangerous?
Yes, it is. Thanks for question about antibacterial water treatment. It's not dangerous if it will be an small amount of the silver, Yep. Has works, for example, Panacek obtained the diatomite with PDDA with silver and investigated the antibacterial water treatment. And Guzilini make the win on kaolinite for the filters for antibacterial water treatment, and it is show a good results. For example, in the dispenser has antibacterial after using, and when use this composite, it was this good efficiency for water treatment. Yeah. And how about how many times can be that use? This material only used one time. For example, because this composite has bacterial strains and which died, and the nanoparticles which this modified here.
So, like, if you can use it for antibacterial agent, right? You may introduce a heavy metal in the wastewater. So, like, it's also not very good for the environment, in my opinion, right? So most probably you need further experiments to determine how stable are the composites, right? And right now, like, what would be your next steps? How would you model the further experiments with the composites to prove that they are stable?
Oh, okay. How it's stable the silver on the supports, on the mineral in the mineral matrix. It is this the using of mineral matrices is good to prevent of agglomeration of silver and the emission. It is this stable for silver. And how it the next stage, how it's stable more, it is will be I think it will be must starting by desorption. Desorption, how it will be, how many silver will be desorbed on the solution from composite. Yeah. Thanks for question, and I didn't make that. How it's stable? How many silver can be on the solution, and how many it will be on the composite? It will be show the stable of the silver on the support.
Like, you would go to the lab, and what would you do? What?
Okay, maybe I didn't think about it when I can do, because I have plans to studying to cytocompatibility of that cytotoxicity. Yeah, yeah, and maybe this unstable. Yeah, in the future it will be new investigation. Yeah, thanks for recommendation of that.
Okay, thank you very much.
Thank you.
Okay, thank you. Dr. Balash, please, you have another question?
Yes, just when there was a nice discussion about slide 9, so I was looking at it for a long time, and then I had an idea what to ask. So if you can go to slide 9, please. This is 9, yes. Actually, I wanted to ask about what is the mechanism of the formation of this, let's say, silver chloride and silver. Just I have experience from my own research that I was also using a material where chlorine was present. So it was actually some plant materials, and we were milling them, I mean, solid state processing of this plant with the silver nitrate. And depending on the concentration of silver nitrate that we used, we could at first observe the silver chloride formation, and only then the silver started to be reduced, because it's like a, let's say, more simple for the material for just ions to react than the reduction process starting. So actually, I guess in your results, we could maybe think about something like this. If you check the intensity, the ratio of the intensity of the silver chloride 6 and silver in your work. So if you compare, for example, 4.65 and 7.21, yes, concentration. So if you look at the intensity, so I guess it's like when we take the sample where the highest amount of silver is present, so there this ratio is like higher in favor of silver, of elemental one, and for the lower concentration it's lower. So have you actually look at this, let's say, chemistry behind, or you just use it as a characterization method and that's it?
Thanks for question, and we only characterize that. Yep, and we can see the, for example, in the peaks when the concentration it is this increasing, the peak is more higher than it was in concentration. It is lower. It is this formation of silver chloride and silver nanoparticles. Yeah. And in this work, we not artificially added the sodium fluoride. It is from impurities. Yeah, it is this first ion exchange reaction, and after that reduced, yeah, with hydrogen peroxide.
Okay. So I just wanted to highlight the same thing that we observed in our research. So basically, if you use less silver, so the first thing that is going to happen is that it will react with fluoride anion, and only then, if you have like more of it, it is going to be reduced. Yeah, so I think this thing can be seen from those results. So that's fine. I just wanted to discuss a little bit about this. Thank you.
Thank you.
Okay, so Dr. Shmakov, do you have another question?
Yeah, thanks. It's just a follow-up question about the silver nanoparticles versus silver chloride nanoparticles. Was there a reason why you didn't investigate this nanoparticles separately? Like, for example, synthesizing only silver nanoparticles and comparing them to only silver chloride nanoparticles in terms of their antibacterial activity?
Thanks for question. And about the separately of the silver chloride and metallic silver nanoparticles, the hybrid particles, silver chloride and metallic silver, and some hybrids which we obtain, it's now the result shows that the hybrid particles has more cytotoxicity than metallic silver or the chloride nanoparticles of silver. And hybrid particles, it's like a synergistic effect. It is more less cytotoxicity, and it's a new trend of studying than only pure silver and pure silver chloride.
Okay. And second question, after I heard other questions on this topic. So I think you mentioned on one of your slides that you used another reducing agent, it was ascorbic acid, I guess. So was there any reason that you did not try to use and compare other reducing agents within this work? What if, for example, ascorbic acid would work better for antibacterial properties of the final nanoparticles?
If we worked with ascorbic acid, and this result we published in this abstract. Yep. In the abstract. Yep. It was this METIC conference, this nanocomposite, yes.
And did you study the antibacterial properties of that?
Yes, we studied antibacterial properties, but it was a different method. It was well diffusion. It's well diffusion method. Not minimum inhibitory concentration. It was different method. With different bacteria, yeah.
Okay. Thank you.
Thank you.
Okay, thank you. Okay, I have a couple of questions. First question is about this scheme of synthesis. I think, Can you go to that slide with 3 different procedures? In the end, it was in the end. In the end of presentation, this process something next one. Yeah, process flow diagram. Yeah. Okay. What about quality control? Do you need quality control somewhere here, in the middle or only in the end? And what type of quality control methods do you need?
Thank you for question about quality control. Okay, sure. We need the control on the last stage, on the when we obtain and the composite and compare that and which of the control. It is the amount of the silver which of on the composite, and sure it is this to control that we must investigate the cytotoxicity, biocompatibility of this material and make some standards of the controlling the reference and the following the products of composite.
Okay, so you didn't study this like quality control issues,
No.
but did you calculate the cost of these procedures? The cost, actually, how close are your composites to the commercial application?
Thanks for question about the costs. About the cost, I didn't calculate, and about the cost, when if we compare the composite to hemostatic agent from USA, this price equal to 4,000 tenge, and the price of the pure kaolinite it is 140 per kilogram, and diatomite it is the same. It is this deposit of that, and it is more cost. It is will be in the economical question. It will be more use for Kazakhstan and use this natural diatomite and kaolinite in our industry and produce this plastic, paper, and compositions for in the cosmetics, pharmaceutics. Yeah, because we're only exports to us from another country.
Yeah, but you didn't calculate the cost.
No.
Okay. And my last question is about the journals for publications. How did you choose them? Why did you choose these particular journals?
It was the relative of the title of the research in the materials, and the colloids biointerfaces B. It is this works about of silver and silver nanoparticles. This published in this journal, colloids, and biomimetics. It is related with those biosilica. Biosilica. It is this journal with published with this macroalgae and the products with macroalgae. That on biosilica.
Okay. Thank you. And it was the last question. Dear colleagues, do you have other questions?
Thank you.
Okay, Dr. Muzhaeva, you have a question?
Yeah, I have a further question to the slide 22 and 21. Yeah, this one. So, no, the next one, 22. So here you have 461 for silver, and then you calculate the ratio, and you have the second line, which is 520 silver. Is it a different experiment or is it a replicate? And why did you take 461 then for the title, for the first column?
why we choose it is this from this of SEM-EDX analysis, and 4.61 it is from this squared, this area, it is a big area, and for example this another it is this from circles, it is this amount of the silver, it's not all area of this surface, and we choose this 4.61 for all area, not only the small areas of studying analysis.
Okay, thank you.
Thank you.
And the next slide, 23. Here you state there were 120 particles used. Which type of distribution was used to fit the particles to determine mean value, average value? Is it Gaussian statistic? Is it Poisson statistic? Is it log normal statistic?
It was it was a statistic from result of this histogram.
Which model?
This is a poly model. This is one model and second model of the particles.
But you write that the mean value is 7.5.
Because it is this mean, this of 7.5, it is this higher of this amount of the silver. We can see in this histogram.
Yes.
Calculated here to depend to another of this amount of the silver in this another size of particles.
But most probably you used origin for the data analysis, and there you choose different types of fitting. You fit it to a model to say where is the mean value. So if you have like normally you use Gaussian distribution, and if you have low number of particles, then maybe some other distribution fits more. Okay, but most probably you didn't go to this topic.
Okay, thank you.
Thank you.
Okay, thank you. You have more questions? No? Okay, can you show the slide number 22? I was thinking about the rounding. So you provide the rounding, for example, 44.8 for silver chloride nanoparticles, 44.8 plus minus 491. Yeah, why did you report in such a way these numbers?
Uh, 44 and minus 4. And this is or why I was
yes, right. I'm asking about these numbers. Why do you report them in such a way?
It is the standard derivation of this percent of the chloride nanoparticles, metallic silver nanoparticles.
Yeah, but why do you provide, for example, 3 significant figures in the standard deviation? So 4.91 is a standard deviation, correct? Why do you provide 3 significant figures? 4, 9, and 1. Three significant figures. Why do you provide 3, not 2, for example, or 1?
We now this of the result from this of 4 the areas of this elemental composition in this area of was provided in the calculating of this the amount.
Yes, I understand. But
Yes, I understand.
You can report, for example, 44.8 plus minus 4.9.
Mhm.
Why don't you write like that, 4.9 instead of 4.91?
Yeah, it's my bad. Yeah.
Uh-huh.
Mhm.
So you should have the same number of decimals in the mean and standard deviation. Yeah, and three significant figures in standard deviation is too much, actually.
Mhm.
It should be 2 or 1, not more. Yeah, the same, this 85 plus minus 2.64, the same. Yeah, so this is very important because it's a rules of rounding. They are well known. Okay, thank you.
Thank you.
Any other questions? I think it's enough. We have a lot of questions.
Enough. Mhm.
About 1 hour already passed. So we are ready to move to the next stage. Okay, and now the screen is given to the local scientific advisor, Professor Ospanova. So please, Ария Капанна.
Добрый день, уважаемые... Не слышно меня, да?
Слышно, слышно.
Добрый день, уважаемые коллеги. Во-первых, я хотела бы поблагодарить председателя совета, ученого секретаря за хороший квалификационный подбор состава диссертационного совета. Было очень приятно, что работа вызвала такой живой интерес. Это очень всегда мне самой лично нравится, когда много вопросов, потому что это есть, во-первых, стимул для дальнейших исследований. Ну, сейчас я думаю, что говорить о работе нет смысла, потому что полностью она представлена. И как научный руководитель я хочу просто охарактеризовать вот Жанар Болатовну, что сегодня вы видели, она доложила большой объем работы. Мне бы хотелось сказать, что вот на сегодняшний день политика нашего государства направлена на то, чтобы мы готовили молодых ученых. И вот я хочу сказать, что действительно, я хочу с гордостью сказать, что вот сегодня Жанара Булатовна показала все свои, значит, положительные качества. Прежде всего, я хотела бы сказать, что она хороший исследователь, вдумчивый, она подхватывает идею, она ее хорошо разрабатывает, она может поставить задачу, она может показать решение этой задачи, может настаивать на своем иногда. И такие у нас были моменты, когда она считала, что вот это более правильный метод, чем тот, который, допустим, предлагаю я или другой руководитель. Вот. И это было очень приятно, поэтому я думаю, что она достигла определенного результата и соответствует всем требованиям, предъявляемым вот к молодым ученым со степенью, значит, Ph.D. Вот. И хотела бы отметить, что, конечно, 3-4 года назад, когда она пришла ко мне, это был еще неопытный молодой специалист, но у нее очень такая хорошая черта, она всегда любит заниматься научной проблемой с учетом вот современных требований. И вот эта проблема, которую мы поднимаем сейчас, это заключается в том, чтобы постараться, значит, замещать вот многие, значит, глинистые препараты, которые мы покупаем из-за рубежа, заменить своими, потому что залежи наших глинистых минералов, они дешевле, они менее трудоемкие, менее трудозатратные. И, конечно, эта часть работы, она имеет и прикладной характер. Вот, и оно вызывает живой интерес со стороны работодателей. Вот, поэтому я думаю, что сегодняшняя защита показала, что она достигла определенных хороших результатов. Я думаю, что она действительно достойна звания молодого ученого. Вот, это наша, я думаю, классическая школа нашего химического факультета. И хотела бы еще раз поблагодарить всех членов совета, значит, наших оппонентов, которые задали очень хороший вопрос. И эти вопросы дают нам возможность дальше выйти на другую финишную прямую. Решение этих вопросов – это украсить только эту работу. Вот. И особенно я бы хотела отметить, я сама член разных советов, но сегодняшний состав совета, я еще раз хочу поблагодарить председателя совета, ученого секретаря, что был очень квалификационный состав, и я всем очень благодарна. Спасибо большое.
Спасибо, Олег Ивановна. Dear colleagues, do you have questions to the local scientific advisor? Okay, thank you. Спасибо. So now the screen is given to the foreign scientific advisor, Professor Miroslav Sprinsky. Please. Your microphone is off. Your microphone is off. Okay. Now it's on.
Oh, okay. Good
Great.
morning.
We can hear you.
Is okay? Hello? Hello?
Hello, we can hear you. Do you hear us?
Yeah. Is okay?
Yes, it's okay. So now you can say, could you say a couple of words about this dissertation work and about the PhD student?
Okay. Good morning. Ladies and gentlemen, and the first, I would like to thank you for inviting me to defense of Ms. Bekissanova doctoral thesis. Zhanar presentation was a very good certification for me. Thank you very much, Janar, for presenting your work so well, and thank you very much also for all of the interesting and hot discussion. Our dissertation concerns very current research topic related to the synthesis of nanomaterials, nanocomposites, nanoparticles, and especially civil nanoparticles, and their application. In this case, it's in concert medicine, because nanoparticles which composite nanocomposite with antibacterial properties. So this work is also interdisciplinary. Generally, I want to say about nanomaterials. Nanoparticles previously was now colloid nanoparticles. It is part of colloid chemistry field, but now name it nanoparticles. Okay, I accept that. Why were silver nanoparticles chose? Silver nanoparticles due to their unique chemical, optical, catalytic, thermal, electrical, and antimicrobial properties have become the subject of natural interest for scientists from different fields, chemistry, physics, biology, and modern technology in application. The unique feature of silver nanoparticles may seem attractive for a wide range of application in fields like catalysis, optic, microelectronics, textile, biomedicine. Of course, many chemical, physical, and biological synthesis methods have been developed, and however, the most synthesized methods use harmful soil reduction agent, sodium borohydride, ammonium formaldehyde, or another, and stabilization agents to prevent nanoparticles aggregate. The toxicity of reductants and economical aspect also are weakness of this approach. Furthermore, the use of nanoparticles that are synthesized in such way can lead to environment contamination. Therefore, in this work, we'll use new techniques of serial nanoparticles synthesized to solve this problem in use environment-friendly materials, which are appropriate supermassive and non-toxic reduction agents, or its legs are development. In this regard, the fundamental idea of dissertation work of Bekissanova Zhanar was to develop an innovative approach methods for the synthesis of new nanocomposite materials containing severe nanoparticles with antibacterial properties, based of diatomite, kaolinite, and diatom biosilica obtained by diatoms growing in laboratory condition. She successfully coped with the assigned task. For the first time, antibacterial nanocomposite based on diatomite, kaolinite, and based on diatomite biosilica synthesized. What is important in this investigation, for example, in antibacterial study, we use only species from laboratory, and also the species of pathogen from clinic isolates. The physical-chemical properties of the synthesized composites Жанар characterized using ordered instrumental methods. During the period of execution and writing of the dissertation, Жанар demonstrates his erudition, inquisitiveness, and diligence. Good organization and diligence of Жанар enabled to cope with achieving goals of the planet states. We already, before start of next experiment, we joking, Mr. Fix, has you any plan? In my opinion, it was too pleasure for me to collaboration with Janar. I think university, Al-Farabi University, can be proud from graduates like Janar Bekissanova. In summary, I want to say the doctoral thesis of Bekissanova Janar is an original solution of the scientific issue and brings some interesting novel results that have terms of cognitive and economics. Taking into account a good achieved results, high quality and impact of the research performed, I recommended award of Ph.D. degree for Bekissanova Жанар. Thank you very much for your attention.
Okay, thank you very much, Professor Sprinsky. Dear colleagues, do you have questions to Professor Sprinsky? Okay, thank you. If there are no questions, then we go to the next step. Is now the screen is given to the first official reviewer, Dr. Shmakov. Please, you do not read. You do not need to read the review. So now we will share the screen with the review, and then you can just highlight most important opinions about the dissertation. Okay, just a second. Can you see the screen?
It's been loaded. Yeah, I can see it now.
Okay, great.
Yeah, thank you. So again, congratulations to Zhanar Bolatовны on this work. I think the work itself is interesting enough, and I think it's there merits to award the degree of PhD for this work. Of course, there are things that I would rather see in the work. I wanted to see it more systematically studying, like, for example, size of nanoparticles, statistical analysis of nanoparticles. I would also want to see more comparison with similar systems. Maybe some of the things that the proof that this concept could be used in practice. But overall, I think the work is interesting enough. And as I said, I learned something from this work myself about diatomites. I didn't expect them to be so fancy and with all the shells. But yeah, I think silver nanoparticles can be stabilized with different types of matrix materials, and I see why specific types of materials from Kazakhstan were used for this work. So I hope that this will at some point will be applied in practice and expanded to other types of nanoparticles using in catalysis and other fields. And so yeah, so these are my comments, and thank you again for inviting me.
Okay, thank you very much, Dr. Shmakov. And dear colleagues, do you have questions to the first official reviewer? Okay, there are no questions. Then thank you very much for a very thorough review of the dissertation study, yeah, and your recommendations, very important questions. Thank you very much. So your recommendation is to award the degree, yeah?
That is correct.
Okay, thank you very much. Okay, so now the screen is given to the second official reviewer, Dr. Klivenko Alexei Nikolaevich. Please.
Comments of.
Comments, please. I'm sorry. So there are comments. I forgot to open them. Reviewer comments. Okay. I will share the screen with the comments, and then I asked Жанара Болатовна to respond these comments. Maybe some of them we already highlighted during questions, but anyway, could you please respond to these comments? Your microphone is off. Could you please turn it on?
Thanks for comments. Thanks for reviewers for the critical review for my work. And can I demonstrate the presentation where I prepared the answers for comments here.
Yes, sure.
And at the first, why so we choose the support materials as advantages over many other types, and it was, as I said before, it is widely used in the industry, and this ceramics in this drug carrier, and this is claiming unique properties like mechanical stability, wide surface area, high absorption capacity, chemical intensity, non-toxicity, biocompatibility, and thermostability. And this is used in the optics, bone tissue engineering, and bond dressings. And for the next comments, it is the other method of silver nanoparticles synthesis. It is this three road of the synthesis: physical, chemical, and biological. And this with wet reduction method, UV or gamma irradiation, and with bacterial synthesis in biological, and advantages of direct chemical reduction, which we choose. It is this and synthesis this composite. It is this mineral matrix were used as a carrier and stabilizer for silver nanoparticles, and used as environmentally friendly reducing agent is hydrogen peroxide. And for example, for other physical methods, it is this for laser ablation, and some equipments are high pleasure for obtaining silver nanoparticles. And the response to question 3 and how the size of nanoparticles affects the antibacterial activity, we discussed about that. It is this example of the one concentration of composite against 2 bacteria, and this is the bigger size of from 20 to 50 is not so effective than the size is more 4, 6 to 6 or 5 nanometers of silver chloride nanoparticles. And the experiments of the compare pure silver and metallic silver chloride nanoparticles, and this from this work, it was studied the silver chloride on SBA-15 and silver nanoparticles metallic. The silver chloride show more of antibactericidal efficiency, the concentration too lower. And there we can see this in the silver chloride nanoparticles, the concentration, and the hybrid particles average size from 20 more excellent activities than the metallic silver nanoparticles. And the experiment of studying cytotoxicity and biocompatibility of the clay materials. It is this research was studied the kaolinite, the clay minerals. It is, for example, in this the control and kaolinite not so cytotoxic for another, for example, graphene oxide. It is this low cytotoxicity. Yeah, we have a plan to investigate of the cytotoxicity biocompatibility of this material, and it is this products from clay minerals. It is widely used in this pharmacy. It is for medicine. It is this cosmetology. There are was investigated before. And the experiments preparing the prototypes and formulations for dressings, and now we has run funding to prepare the hemostatic composites based on kaolinite, and this is planned to research. And now there's the prototypes of this composite with the composite hemostatic with kaolinite with hydrogels. And in the future we will to make the prototypes and preparing for wound dressings. And thanks for your revision and comments.
Okay, thank you. Dr. Shmakov, are you satisfied?
Yeah, I think the responses are thorough, and I see that the work is continuing. Especially, I'm glad to see that it's not stopping here, and it's going to be applied in specific prototype materials. Thank you.
Okay, thank you. But as I see, there are only recommendations to add something to the dissertation. Yeah, but there is no, it's not possible to add because this dissertation is defended on the series of articles published in the peer-reviewed journals. Yeah, so there is no dissertation. So that's why it's really not possible to correct. But there is nothing to correct, just to add something more, but I hope it will be done in the future. Okay, thank you. And now the screen is given to the second official reviewer, Dr. Klivenko. Please, we will share the review, and as I already mentioned, there is no need to read the review, the text of the review.
Okay, thank you very much for inviting me as an official reviewer of this dissertation. And only one disadvantage of this dissertation is there is not a dissertation, it's just a series of the articles, actually. So, and may I stop only on my questions to the applicant, because it is main what I would to ask. So, in the provision one, you say that my question concerning actually to the elemental analysis as well, and you show that your composites contain only some elements. So, and you don't show the content of hydrogen on other elements. And from the first paper, which was published in the materials. Sorry. Yeah, materials. You show that original diatomite does not contain sulfur in its composition, whereas the composites contain 0.2, 0.4% of sulfur. How did it appear there? The same question about calcium, and where is hydrogen as well. And the same time, you show on the TIR spectroscopy results that is some groups as aluminium OH, silicium OH, and HOH as well. So was hydrogen inside of your composite or not? And in this this question about the composition, is it true that the composite may be not be equal to 0.71%, 4.65%, and 7.21%, as it's stated? So, and the same questions concerning to second and third provision concerning to the elemental analysis. Yeah. So that's all. But in the general, the publications is in very nice journals with high level, and I think that we should to award the degree of the Doctor of Philosophy to the applicant. So thank you very much for your attention.
Okay, dear colleagues, I just showed the reviewer comments. Did you see them?
Yes.
On the screen. Okay, thank you. Okay, Жанара Болатовна, could you please respond to these comments of the second official reviewer?
Okay, I'm grateful for reviewer the thesis, and I want to show this about the first question. About this, the first question of the original diatomite does not contain sulfur in the composition, where the composites this sulfur. And the diatomite, it is this from reduction and decomposition minerals from the diet algae, microalgae. And the diatomite from Gajar can have some impurities of the sulfate minerals and semidic spectrum. And why didn't the natural diatomite, depend of the different surface of area of semidics of square of some small impurities of the sulfur of content. And this is the example of where the different diatomite, for nature example, has a sulfur. And the next question about the catone, where is it disappear? And we can see the sum of the results show marked the exchange of cations, sodium, magnesium, aluminum, and potassium and calcium was decreased. There was exchange reaction, the formation of soluble nitrate salts. And the next question about where is hydrogen for soil defense, provision defense, and this is of depend of the semi-index energy dispersive analysis, and it is they don't identify the element except for hydrogen, helium, and lithium. This can be probably to indicate in this ADX spectral analysis. And this small amount, it is make some bound in IA spectroscopy. And the distribution was calculated, as I said before, with these two, with analysis MHG and origin. And thanks for your revision and comments. I'm grateful.
Okay, Dr. Klivenko, are you satisfied with the response?
Yes, yes. Thank you very much for your answers.
Okay, so in your review, I saw that you confirmed that all provisions are proven. Is it correct?
Yeah, yes, it is correct. Yeah.
Okay, thank you very much. Okay, dear colleagues, do you have questions to the official reviewer? Okay, thank you. If there are no questions, then we can go ahead, and now we can start the discussion. So during your speeches, could you please comment on the correspondence of the study to the principles of independence, internal unity, scientific novelty, reliability, practical value, and academic integrity? Yeah, so please do not vote, do not tell how you will vote, because we have a secret poll. Yeah, so please comment on this on your if you see some errors, if you have some comments, and just about these principles. Yeah, so because our decision should be based on the principles which I just mentioned. Okay, so please, who wants to speak? Yeah, I expect that all temporary members of the dissertation council will speak, because your opinion is very important. You were invited as experts in this field. Yes, so please tell about the study. You asked a lot of questions. So could you please comment on these principles?
Okay, so maybe I can start, because I had also the first question, so maybe I can also say a couple of words.
Okay.
Yeah, so actually, I think this work is, as I said also when I started asking questions, is very well performed. I guess it is in line with the research that is going on in the field. I think also, like, let's say, about some international cooperation works very well here, because we saw that we have like authors from different countries, even from different continents here. So it's nice, I think. In general, yeah, I think the work is well performed. I just I think I also highlighted it during the questions. That there are some, let's say, weaknesses, but these are not like, let's say, hampering the awarding the PhD degree. At least this is my opinion. But I just would like to highlight that actually it was more times here that the silver content could have been determined also by other methods, so not just by SEM-EDS, but also, for example, yeah, like the dissertant mentioned ICP. So, or I think just basic atomic absorption spectrometry would do the trick also quite nicely. Also, in the last review report that we heard, so there was a question about sulfur. So actually some elemental analysis like CHNS analysis could have been done also, and this would solve the issue with both sulfur and hydrogen. So this could also like be of added value. In general, I am a big fan of X-ray diffraction, so I think it could have been used also more. I mean, the results that were shown in the work could have been used like could be elaborated to more detail, like to determine, for example, the crystallite size of silver and silver chloride, or also, like I said, to determine the ratio between the two components could have been done using this way. Also in the work, I saw that there are no, even in the papers, there are no PDF cards, which are like telling us about the cards of these crystalline compounds that can be found. So this could also have been added. And the last point that I saw, that during the TEM analysis, also the selected area diffraction could have been done. So by this method, it would be possible to, let's say, distinguish between silver chloride and silver. In one of the papers, it was done based on the color, let's say, difference. So the, let's say, lighter particles were silver chloride and darker one were silver. But it would have been better to distinguish. From our research, I know that we often had this combination, and it was possible to do this. So actually, like these were like the points that I see as the weaknesses. But in general, I think it was very nicely done. And like I said, I think it's within the trend in the world, and definitely, I think deserves to be awarded the PhD. Thank you.
Okay, thank you very much. Okay, dear colleagues, who wants to speak?
And maybe I can continue.
Okay, Dr. Możaeva, please.
I also reviewed the articles, and it was interesting to read the work. And I basically, from my questions, you could basically notice that I have some comments to the mostly elemental analysis, and it would be also interesting to see how this work will continue and how the further experiments will be done to see maybe one of the results of the work in the commercial application. Concerning the scientific principles, I didn't notice anything that is against them. So, in my opinion, the work could be awarded, the candidate can be awarded the PhD.
Okay, thank you very much. Okay, Dr. Shmakov, please.
So for me, I think the important part was that Zhanara did this work, a lot of this work herself. So I think this is one of the important parts that shows that the readiness for this next level. I had some questions about novelty and significance. I wish the work was designed in a way to showcase why these methods are really novel, what contributions they make to the common knowledge. Because, for example, antibacterial properties of silver, they're known like for centuries. So nothing groundbreaking there. So it looks like the clay minerals are also well studied. So if I were designing this work, I would probably try to make it more systematic to show the trends and why this work is really novel and significant. But other than that, I think the work is interesting at the very least, and I think there's good potential that it can be used further. So yeah, that would be my comments on this.
Okay, thank you very much. Okay, Professor Efremova.
Thank you. I would say that firstly, I read abstract in Russian, And you know that it was interesting for me because I had many questions. And after reading abstract of this work in English, I found answer my questions. It's interesting, but it is true. I would say that today we could see an example of good defense of Ph.D. Thesis, and it is a good job. And in my opinion, the applicant deserves to be awarded PhD. Thank you.
Okay, thank you very much. Okay, dear colleagues, who else wants to speak?
Can
Артем
I?
Ленин? Солдат Минибекова, пожалуйста.
Да. Thank you.
Please.
Dear colleagues, today we have very interesting work of Bekissanova Жанар, and if you should validate this work on truth, reliability, relevance, and practical importance in this connection, I should say that quality of this work is very high, and and the relevance for our country is in the fact that we need our country need in the production of new materials, and these materials are based in our natural minerals, and it's very useful from the point of economic. And in second, I should note that this work has a very good publications in 5 journals with quartiles 1 and quartiles 2, and Zhanar have 2 patents, and these patents are evidence of practical useless of this work. And if about truth and the reliability of this work, using of modern research methods and accordance of the results obtained by different methods is evidence of reliability of her results. And answers of doctoral student on question her knowledge, deep knowledge of mechanism of formation of composites, and knowledge of about these methods allow us to award for degree of Doctor of Philosophy. Thank you.
Okay, thank you. Okay, dear colleagues, who else wants to speak? Okay, I would like to add a couple of words. So it was a very interesting defense, and I think from what reviewers said from questions, it is clear that all principles from the rules are maintained, Yeah, so there are some comments which should be addressed in the future, but I think it's normal, it's okay. The PhD student could defend the results, knows everything very well about the work because she did it herself, most of the research. Yeah, and she's the first author in the articles. Yeah, so I feel that this work has a very good quality. Yeah, and in my opinion, it deserves the degree. Okay, so I would like to give the last word to the PhD student, Жанара Болатовна. So you could say a couple of words in the end.
Okay, I'm grateful. I'm grateful for Dissertation Council, and I'm grateful for reviewers and for question and discussion. It was this lot recommendation and comments how to improve the work, it's going ahead of this research. It was very useful and critical comments. And I'm grateful to supervisors, for Professor Miroslav Sprinsky for supporting, and to in the research, doing PhD, during this internship, for productive collaboration, for Professor Spanova for supporting in this part of this research, for works in this grant funding, where was supervisor of this, Professor Spanova, and discussing of work. And thanks for your attention and your time to make this discussion of work and the defense so interesting. Thank you.
Okay, thank you. Okay, dear colleagues, so now let's move on to the secret poll that will be conducted here in Zoom. Yeah, you will see it on the screen. Yeah, so all members of the council and official reviewers must vote. So we have 8 people, and 8 people should vote. So for other defense participant, the break is announced. So you should, I will move you to the waiting room. Okay, so PhD student and 2 scientific advisors will be waiting in the waiting room, and then I will connect you back. So please do not disconnect. I will do it just by myself. Just a second. So please wait till we finish the process. Okay, now we have 8 people, and I will also have to connect because I cannot vote as an organizer, so there is a limitation in Zoom. So I need to connect from another, from my cell phone. So I'm sorry, I have to log in.
Recording in progress.
So it is me. So I start the poll. So you will see it on the screen. And please vote. We must have 8 votes. Okay, we have everybody. I'm sorry, just I need to make a screenshot. Okay, I will connect the supervisor and the PhD student. And then I will show the results. Okay, dear colleagues, we finished the process of the secret poll and I'm ready to show the results. Okay, so now you should see the results on your screen. Yeah, so we have 8 votes to award the PhD degree, and based on these results of the secret poll, I officially announce that we award the PhD degree to Жанар Бекисsanova. Yeah, and my congratulations to you. Just a second.
Congratulations.
Yes,
And
congratulations.
Thank you.
I closed everything. Yeah, so I would like to thank everybody for a very active participation and very interesting discussion, questions. The defense was very interesting, and I think we made a great work today. And thank you very much.
But one question.
Everything. Okay, do you have questions about this?
I have a question about review of our reviewer. Is it we should change this review of Professor Shmakov about the word dissertation?
No, it's okay. It's okay. It doesn't matter. Yeah, so we have dissertation on the series of articles.
But all articles together make dissertation?
Yeah, so there are 2 words, dissertation and dissertation work, in the rules. Yeah, so actually it's dissertation work, I think. Okay.
So may I ask you
The
about the review? Should we send the hard copy of this with the stamp, or it is not necessary? The PDF copy is enough or not?
Yes, you should send the, but I think no, Sadat Mizbekovna, I think it's not required, yes, because it was provided. And
about original of this of review.
Yes, about